So I need to copy the link and put it to my Google Play.
Yeah, you can do that.
Mm-hmm.
Here. Um, yeah, however you want to go.
Right there.
This one?
Oh,
You
it's
can
right
do, you
here.
drive.
Okay.
Nice outbreak.
Mm-hmm.
Mm.
Then link. That's it, right?
Yeah. And then if any of them reach out and they have problems with the link, they could just go to the Cloud 901 YouTube page.
Okay.
And we'll be live streaming from there. They could get to it that way too.
Okay. Okay.
But see that red dot, how it's a red circle? I mean,
Mm-hmm.
it's active.
Okay.
And if you need to adjust it, I had it up kind of higher because see how the windows are up there?
Mm-hmm.
If you go level, it's going to have a big glare on the
Okay.
screen. So kind of up that way, it works.
Okay. You have the dongle for. Thank you, Carter.
Yeah. Just let me know when you're done and I'll come get this
Okay.
stuff.
I don't know where the box is that had all the mouse parts.
It's not cleaned up. How much it put all the 3D printer?
Yeah.
All right, here's this.
Thank you. Hello.
Let me go downstairs. What did I do? Yeah. No, what? No, I didn't do it. What cook? Yeah, no, man.
This game was bad. I didn't watch this game. There was a game where it was like 13-6. Even though it was 3-16. This is professional teams.
That's not that bad. Trust.
They kicked one field goal.
That's a great.
One field. They are a professional team.
Yeah, like when you're talking about fixing on wood. I want that diesel. You also. He does it. First, camel.
CEO marketing.
No, you had it right before. Right, what is the action? Right, no, right, that's all. Right.
I guess you say,
Oh, wait. Here's the motion. Okay, so what's the thing?
the song.
Um,
What did she say? The song.
you got that part? What is that part? I'm gonna take some live.
Okay, wait, what? All right, go down.
Go with me. In the, so the word. So, hi. So, who right? Great deal. Wait, not right way. Okay.
Hello and welcome.
Okay, so what is true? What are we together? Oh, and like we're in a room with something like it's okay.
We got one from the thing. Yeah, no, you didn't.
Okay, so.
It's you. It's you. You're a true one. You're a true one.
Okay,
How's it going?
okay.
How do you say it?
Or cry, go, cry, water, cry, sleep. Oh, like some people don't work with that. Look at that. Yeah. Okay. When you look.
What color is it?
Okay, that's what you're
When you
saying.
give up an award, what color is it?
Yeah, okay. Okay, see what if you sound like, because I rather sit at home and have this like. Okay, not 5 years, but. You said many months, not 4.
All right, so we'll be getting started in about 2 minutes. We're waiting on a couple of items, but we'll start soon.
Like, look, yeah, Kirsty's face.
I'm not excited. You got it.
Oh, okay. Okay, it's not as good right here. Yeah. I'll do that here. Yeah. No, I'll call right. Oh, okay. So maybe
Just do it. Just go. What's up, Master?
now you can. Not a good one, but okay.
That was a good day. Gotta go. Gotta go.
Okay, oh, my girl wanted M&M, so I gave her M&M. Did I say M&M? I'm sorry. I'm sorry. We sorry. Okay, like she had like, she must be 10, 10 on 10. She was 10 on 10. That, okay, cool. Okay, it's a game. It's all I know. It's like a, it's like this and all that. And you can like.
All right, y'all gonna be on this, in this area right here? Yes. I want y'all to do the, zero, no talking, no videos playing out loud or anything. Because we're going live up here. All right, I found, come on, mouse. The mouse are missing, you know. Here we go.
Okay, in French, in French. Okay, so you just write it.
I'm not sorry.
Okay, here it is.
Oh, wait.
Okay. Okay, if I were crazy. Okay, okay, big, so they're really, they're super. And like, A3 always wears
Okay.
I'm gonna go ahead and get started. Is that okay?
Okay, yeah, that's fine. In,
He said he's tired.
we go.
He
Get
said
behind
he's
the computer.
tired. All right, y'all. We're gonna go ahead and get started. So my name is Miss Jazz. Hey, how you doing? I want to make sure I get everybody's names down before we begin, because I will be calling on y'all, asking y'all questions, because this is a discussion. So Ian, right? Yeah, you tired? Huh? You okay? All right, I'll leave you alone. Can I get your name?
My name is Kennedy.
Kennedy. Okay, so I got Ian Kennedy. Lee. Lee. Nice to meet you. And
Names.
I know Devin. Donovan. Goodness, that was close. So Ian, Kennedy, Lee, Donovan. All right, so feel free, sit down where there's a laptop, and we're gonna go ahead and get started. How you doing today?
Good.
Nice.
Are you showing like SolidWorks?
We're going to talk about the basics of reading engineering drawings. the very basics. For actual CADing practice, I'm more than welcome. I'm more than willing to do that, but that takes time. That's more of a in-depth conversation.
Yeah.
Yeah.
So I'm gonna be sitting at your desk a lot, just watching.
Probably.
Okay.
But if you guys have questions, I'm here. You guys have various resources to ask questions.
So Miss Marion's going to be getting a drawing for us to look at as an example. But what I want to talk to you all about today is just your general experience, concept, anything related to measuring things, dimensions, stuff like that. So I don't know how old everyone is, but I'm assuming that you all are used to using the metric system. No? It's okay if you're not.
I can use it.
Okay. You can use it.
It's pretty easy. It's basic.
It's base 10. It's real easy. Probably, I would say a lot easier than our standard U.S. imperial system, but that's just my opinion.
I have the same opinion too.
It's a lot easier.
Unless you're using the engineering system, which is also based on
Yes.
changes everything.
That changes everything. Yep. All right. So when you are looking at engineering drawings, you're going to see a couple of things. Kennedy,
I have one. Yeah.
yeah, that'd be great. Can we use yours as an example real quick, please?
Do you want my computer?
Probably just leave it here. I'm just gonna use the drawing as an example. Is this an okay one? That's perfect. All right, so when we're looking at this, there's a lot going on, right? Let's say if, let me see if I can scroll it. Okay, perfect. So down here, bottom right, you're typically going to see a title block. That's what this whole section is called. And there are different portions to it. Mainly it's to give you a high-level overview of what are we looking at today. What is its name? Who's the manufacturer? So let's say the person who came up with the drawing, the name for it, the actual drawing number, the material. It gives you all of that basic information. Sometimes these title blocks will go into even more detail. So they'll talk about surface roughness, things like that, but that's getting into the real complicated parts. The base thing you need to know about a title block gives you the general information for the part, right? Now, when we're looking at engineering drawings, in America, we look at it differently than how it's looked at in Europe. Now, this is important. So let's say, for example, your phone. For the most part, everybody's phone is shaped like this, right? Now, let's say if I was holding the phone up, can you tell, if you were looking at a piece, like the drawing of this on a piece of paper, would you be able to tell the right side from the left side? Would you be able to tell it all? Not really, right? Thank you, ma'am.
Taylor, she has the large copy.
This is perfect. Thank you so much.
You should put the phone with the mouse.
Yeah, FRC website, go to the tip box.
And go to the tab.
It has drawings, it has the actual
This one is straightforward.
You're just looking for a mouse to use.
I don't really need a mouse. I more need a copy. I want them to all look at the same one at the same time. But I think we will just do this. Yeah. All right. So in Europe, they actually use first view. So they're basically looking at it in a completely different way than we do here in America. The way I like to look at it is, if we're looking at the first view, imagine you're looking at the top of your part. So if we're looking at the phone, we're looking at the top of the phone, right? And you basically treat it like it's a stamp and you roll it. So when you roll it, top view, you roll, you roll, you roll, you roll. And I'm going to show you a video that animates this, but I'm just trying to give you the overview. So first view, top down, you're rolling, right? when you're looking at third view, imagine it's like a box. You're looking top down, but it actually unravels. So let me show you the animation because it does a better job of explaining than I can without a visual. Thank you for your laptop. You don't need any more? I don't think so. I think we're good. Japanese people. All right.
Okay, I'm a dog. I'm a dog. Okay, so your
It was mine.
Okay, Mariah. Young Thug. Boom. Okay, Bobby. 2016 actually. Okay, you're not in the car. Now we did it.
Okay, so here, if it'll load, they're showing you the first angle versus third angle projection, right? So we start off, my apologies, start off with the front view. You know, technology fails you right when you need it. Like as soon it was already loaded up.
The Wi-Fi up here is really bad.
Is it? It's terrible.
Especially at this time, because everyone's on.
Maybe that's it. 'Cause it's
What's going on?
the video that I have to like demonstrate to them. It's not actually
You want
good.
to start here?
Yep, I went and did that whole process too. It's probably just the amount of people on the network. Well, we're just gonna have to get a picture.
Just let it play, I think.
Yeah, I'm gonna just let it go because. Alright, give me a second. I'm gonna find a picture that accurately depicts this instead of the video. My apologies.
It's like a wall.
Anybody need, I don't know where Taylor put the mouses. I really don't. But somebody can borrow my mouse if you need a mouse. For needs a mouse.
If we're doing any type of CADing today, I mean, they can. I didn't plan on going into using the CAD software.
Okay.
Just the basic reading of the
Okay,
files. Is that fine?
that's fine. Yes.
Okay. All right. So in Europe, they use first angle projections. In the Americas, we use third angle projections. The reason that this is important is because depending on who made your file or who the manufacturer of the product is, it can look different and it can kind of mess you up when you're trying to view your part. So let's say if we were looking, I think using the phone is a good example. Let's say if this is the front of the phone, right? In a third angle projection, you treat it like it's a box unraveled. So you just have your front, your right, your left, your top, your bottom. If we were looking at this in first angle, it would be the opposite. So remember third angle, we had the front, but then it started off on the right. Here you see first angle, it starts on the left. So the creator of this file, where does this group originate from? Do you know?
I'm
Where?
not
Yeah.
sure.
East Coast United States.
So we should be good. All of these should be in the third angle projection.
Okay.
So those are the two views. That's the first thing you have to understand when you're looking at an engineering file. Are you looking at the first angle projection or the third angle projection? And that all depends on who made it, right? So since we're looking at a third angle projection, and since we are in the Americas, and that's 90% of what you will see, when you're looking at a part, you want to understand you're looking at the front view, right, left, top, and bottom. Now you may be asking me, well, we're looking at, just this one flat part. Why don't we see a top, left, right, bottom, all of that? For this is something simple. It's likely just a plate. So when I look at this, I can tell, okay, this is the top part. They've got this little view off on the side that you can barely see. Take that and pass it around. Just take a look at it. You can see those two views on the sheet of paper because that's all you really need to know because it's a plate. Everyone see that small section on the right? Yep. So if we look at it, does everyone understand what they're looking at when they see that? Honestly, no? Okay. So I'm going to try to use another example. That isn't not too complex. I think this one's good. Does it matter if I mixed up the order? Okay. I'm sorry. Yeah. I guess I can move it. Okay. So here's another example. In this, we're looking at the front. Here's the right, here's the top, and then when they have the picture go off to an angle, it's typically an isometric view, that's what we call it, right? So if you were looking, you have to think about this in like the 3D. Because it's 2D, they can't show you everything like this view without showing you all of the dimensions for the part. So that's why they have all these different views. So when you're looking at this, what part of it is this?
The front.
Yes, this is the front. It's the front. So it's showing you the front, the top. What's this? This is the right. So this is why I'm trying to get this down for this third angle projection. This is the basics of what you have to know to be able to see this correctly. So, and you do CAD as well, right? Okay.
Yep.
It's straightforward how I'm explaining it?
Yep.
Okay. So we got the front, the top, right, isometric. So take a look at this one for me, Ian. Just look at it for a second and let me know what questions you have in regards to, hey, this doesn't make sense. We're going to go through a couple more examples. Like this one is kind of complicated. We'll save that one for last. Most of these are just plates. Are these just the outer portions of the, what's this?
The plates are the hoppers, so they're all different polycarbonate sheets, and then you just kind of like
Put them together.
Yeah.
Cool. Okay. Yeah, it's a straightforward assembly. Thank you. So how you feeling? You feel like straightforward? You got it? All right. Look at that one. Let me see. Here's another one. This one is a little more complex. This is a gear. So when we're looking at this, what view is this? You had it. You was about to say it.
isometric.
Yes. All right. So you got this isometric view here, right? We're looking at the front, and then this is turned to the exactly. This is the right. But you see how it's kind of like it's got all these extra lines and marks in it? That's because they're showing you a cutout of it. So they're showing you the inside of the part. So imagine if this were my phone, they basically cut the phone in half so I can see it. And the reason they're doing this is because there are all of these dimensions on the inside that are important. You need to understand, hey, if I'm going to make this, if you were actually to CAD this up yourself, you would have to understand what's going on the inside of the part. So whenever you see like these, I'm forgetting the words, sections, and then they call them hatches, right?
Crosshatch.
Crosshatch, thank you. So whenever you see a section like this, and it actually will show you, it calls it out, section AA. It shows you there on the bottom. We can take that and pass it around. So whenever you see a call out for a section, you know you're looking into the part. And it'll tell you what the section is called. All right.
Does that one have hidden lines on it showing the projection of what's being cut out on it?
It's not even the detail cut out?
No, just the dotted lines, the hidden areas where it's showing.
I didn't see it.
Projection cut out.
No, so sometimes they will like circle it and then zoom in, like the actual detail.
Yeah, or they'll show like what's called a hidden line, which is dashed line, and it will show an area which is being carved out, out into the part.
I want to make sure we're talking about the same thing because it's not a center line you're referring to.
No.
You're referring to, say it one more time.
It's a hidden line.
Hidden line. Okay. I'm going to make sure that I cover that. Let's see. Talk about that one. This one's pretty good. So, another one here. This one's pretty straightforward. What do you see the general isometric view, right? So it's a pretty simple shape. We're looking at it here, and they turn it. You can see this portion of it, and it's telling you, it's actually calling out dimensions. 0.79. Are these?
Those are in inches. I don't know, but they have a metric version. Those are in inches.
We're gonna work with the metric version, right? That's more of a point. Are we working with the metric version?
The rules say that we have to put it in both metric
And I'm about to tell you.
inches and then metric. And
Yep. Because some of the, like, just say some of the part, I just say a motor controller from Bex, it probably say, hey, the diameter is 1.5 inches. I order another motor controller from Edimar, it's probably going to say 50 millimeters. So it's interchangeable.
Okay.
Yep.
So they need to know how to do both. They need to understand a frame of reference for both.
Yep.
Okay, we'll have to do an exercise. Oh, that's cool. We'll have to do an exercise on that so that,
Okay.
yeah, I'll figure that out. But generally, when we're looking at these, I think
This is a good one to show
Yes.
you guys. This is an indication of the center line, and it's got a circle center line that's noting the distribution of where those holes are at. Typically on a lot of these, this is not showing it, but when you have a polygon like this, it will usually indicate whether it's inscribed or outer scribed, so that you can figure out what the overall dimensions are and its geometry. When you're doing hand drafting, that's really important, because as you get into computers, and it's not quite as important, but it's necessary for them to fabricate.
What do you mean by inscribed and overscribed?
So, see here where you've got the width of this hexagon. So this is indicating that that's the width between those two portions. If this was to go across the other way between the angles, that would be outer scribed or inscribed.
Okay.
That's outer scribed with the way it's.
Okay.
Okay.
Okay, yeah, got it.
Cool. And then for measurements, so you're gonna see a bunch of different measurements called out. Sometimes it's just the distance between the datum or the reference surface that we're looking at. Sometimes it's the diameter of a hole. Sometimes it could be an angle, like there should be an angle on there to show all of the holes that are listed. That part is pretty straightforward. Let me see. Because then you get into the how we actually measure from a reference point versus not. Yeah. Give me a second. Let me think of how I want to explain this part.
Might be easier to do it on a table and just kind of.
Say that one more time.
It might be easier just to set it on a table and kind of show them the geometry and where it goes back to.
I want a bigger one. Is it possible to get 11 by 17 for any type of a printout?
Right now?
Yeah.
Okay, let me technically see now.
Okay.
Because I gotta look for it.
If I have to, I can hook up my computer and show them.
Whatever's easiest. If we can get a printout, that works. If not,
Be right back. So how many you want? One for every student?
If you could do 11 by 17 or something like this, that would be great.
Or just this one? No other one?
That one, no.
Okay, one for everybody?
Yes, ma'am.
Okay.
Thank you. This one's good.
I saw that they put different, there's this one specific piece that I'm having, that one.
Yes.
I'm having trouble deciphering, like,
Mm-hmm.
how you're supposed to build it in CAD, especially with these curves. I see that there's some radiuses here,
Yes.
but I don't really know what they're referring to.
Right. So they're calling out a bunch of stuff here. So first, let's just start off where 0 is. And then if you know where the 0 is, we'll call that like your reference point. That's your start. From there, they're going to call out, okay, from this point to whatever hole that they're calling out, there's a distance that they'll call out. Here, they're calling out the actual diameter of the hole. And then the radiuses that you see, they're referring to this curve. It's all the curves all around this.
Okay.
They have to CAD this. You guys have to CAD this.
We don't have to CAD it. It's already CADed.
Right.
I'm just trying to do that practice, and I'm wondering, like, what do these mean?
Okay. Got you. Yeah. So that's why when you said, I'm like, why would they do that to you? So If you were to try to CAD this yourself, you can do it a couple of ways. You can use a spline, you can use a circle, but let's say if we had a circle out here and the center of the circle was here.
Mhm.
This radius is showing you the radius of that circle. Does that make sense?
So are they using like, I don't know if it's like a 3-point curve or whatever the curvy thing on Onshape is, or are they saying this is where our invisible cutout circle is and the radius of it is 3 and it so happens to give those portions?
They likely use the spline. So if you go in here,
Oh, this.
yeah. So if you click on that, that basically will make, yeah. And if you hit escape and then dimension, and if you call out a dimension, you can set the radius and it will adjust it for you. Hey, how's it going?
Good. I heard y'all needed some mice.
Yeah.
Okay.
Oh, thank you.
But they're not wireless, so I'm gonna see if I can pull some adapters. Something to pull them off. How many did y'all need?
I mean, 5.
Okay, that's fine. Thank you. I'm gonna go find adapters.
Okay. There you go. Hey, oh, I didn't see that. Did you get one?
I have one.
You have one? Did everybody get one? Okay. This is exercise. And so the general rule, it states that they have to use both. And what is the justification for that?
I think it's just so that they have both of them in it. I mean, it is kind of an international competition, so
I see.
there is,
But I
that's
don't,
typical when I've had to work on international projects. Like when I've worked on stuff in Canada or Guatemala, Costa Rica, they've all required both inches and metric.
and maybe it's just the machine shops that I've sent to. I put everything in metric. Even like the domestic machine shops, they don't. The ones that I've worked with, they didn't mind that I sent it to them in metric.
As long as in a lot of them, yeah, that's the case. Particularly as they've gotten into, with some of the CAD programs, I mean, it doesn't really matter as long as it's in a measurement.
It'll transfer over, yeah.
But that's not always the case, particularly if they're using like a machinist who's actually has to fabricate that part.
Yeah, I send them to machinists and they're typical. Well, no, what I do is I start off in SolidWorks in millimeters, and then I just change everything over to inches because that's straightforward.
Yeah, but
Yeah.
I don't know how long you've been working with fabrication drawings or not. But I know when I first started, a lot of this work was still being done by machinists who actually were cutting the material out.
Yeah.
And so they had to have it in both if it was something that was in metric.
Okay. I've fabricated my own parts. I've fabricated parts for other people.
Yeah.
Just as long as you give me a measurement, you can do it. But I understand people are.
Yeah.
Yeah.
It's just because in the United States, a lot of them, they understand the engineering, and a lot of that is in base 10 still, but if you give them centimeters and they're like, well, what is this? Or they don't have the tools in order to measure it out.
Okay.
That was
I understand.
the rationale.
Yeah. Understood. Okay. I mean, we can do scale too. I think they're not going to use these parts. I'm trying to think which one other topic.
I don't know what this is.
Okay. So, looks like so this is 15, 10. Where is additional? Being that they won't be doing the fabrication themselves, we don't need to go over hole tolerancing. It's just
We will need a little bit, but it's not necessarily for the whole tolerances, it's just so that they have the understanding of competition.
got you.
Because some of the things that are going to, a lot of the obstacles and the things that they need to interact with, there are precise measurements